And what we've said about simplifying trig functions when there are squared terms involved is to go to your Pythagorean identities. Now, I had to put all of them in one place on the sheet so that you had one great big list of basic substitutions that you could make. The squared terms that lie in this question are telling you to look to that section for those substitutions. So you actually have three options here, and I will tell you what they are. My first option is I have a Pythagorean identity that replaces secant squared with 1 plus tan squared. So if I wanted to, I could replace this with 1 plus tan squared. That is a legal substitution and would be viable. This is secant squared minus 1. My second option is using that same trig function. If I subtract 1 from both sides, I have a tan that is squared. And I can replace this thing with a tan. Do you see it? That is squared. So my second option would be leave the secant squared on top and make the bottom be a tan squared. So in the first option, I replaced the top, I left the bottom. In the second option, I replaced the bottom, I left the top. My third option, replace them both. And if I replace them both, I end up with 1 plus tan squared over tan squared. Now, I want you to learn to think through your options before you jump. Because if you jump too quickly at the first thing you think of, you could be creating for yourself an algebraic nightmare. What I'm looking for is the one of these three choices that looks the simplest. Which one looks the simplest? I'll label them here. This is choice 1 in red, choice 2 in blue, choice 3 in green. You like 3?
Yeah.
What is it about 3 that you're liking?
You can cross out the...
No, you can't. Remember your factoring rules. When there is a plus or a minus hanging out there, you cross it all out or nothing at all. So can you cancel that? No more than you could have canceled here at the beginning. I couldn't cancel that either. Now which one looks the simplest? 2. Choice 2 is heads and tails, the simplest of these three options. That's going to be the one I recommend you go with. Now, what makes this so hard? You got to know your algebra rules. Because if you don't know your algebra rules, you're going to be going out into left field real fast. So I'm going to take that thing now and I'm going to think again through my options. I've already done my Pythagorean identities and it's still a fraction. So I think I can make this simpler. So I'm going to change everything to sine and cosine. Again, it's going to look at the onset like I'm getting uglier rather than cleaner, but trust me on this one, it works nicely. When I change secant to 1 over cos squared, does everybody know where I got that from? And change tangent to sine squared over cos squared, can you see what's going to happen? Do you remember your complex fraction rules, Joe? That's called a collapsing complex fraction. Do you remember when the denominators collapsed? It's because they were identical. And now I'm down to a 1 over sine squared, which I can unfraction by calling it a cosecant squared. Algebra combined with trig, combined with substitution. And for those of you who are weak at algebra, this has potential to be a bit of a nightmare. The number one thing I need to say to you is the more you avoid these, the worse it's going to get. The more you practice them, the better you're going to get. Do not practice avoidance. Practice your skills. Find some board space. Okay, I'm going to have you start with example 4 from the previous page. which said simplify, sine times cotangent. Go ahead, I'll check it in a minute. Okay, for that one, you should have gotten a cos-x. Anybody need clarification on that one? All right, the way we got that was effectively to take this sine and leave it alone. Sine is already sine. I'm not using the Pythagorean identities in this one. Why? Nothing is squared. A cotan gets immediately replaced with a cosine over sine, and to multiply, all I need to do is find common terms to cross out, one numerator with one denominator, and that only leaves me with a cosine. You're going to try 4b next. For that one, you had two options. Once you changed them to sine over cosine, you could have done what Leah and Rachel did here and find a common denominator for the top and the bottom. Your other option, though, was to treat this like a division statement and to think of it as a 1 over sine being divided by a 1 over cos. Middle school math, how did you learn to divide fractions?
Multiply and flip.
You flip and multiply. So I would have had a 1 over sine times a cos over 1. Either way you did it, you got the same thing. The answer was cotangent. We okay there? Okay, next you're doing 4C. I'm going to explain what happened with this one. Effectively, what we did with this one, we said nothing is squared. We're not going Pythagorean, so I'm going to change everything I can to sine and cos. Sine stayed the same. Tan became sine over cos. 1 stayed the same. And secant became 1 over cos. Now I have a complex fraction. I need a common denominator. The reason I was able to just flip and multiply in the last one and I can't here is this is not one term. The bottom has to be one term to use flip and multiply. So that's not an option for this one. So I'm going to find a common denominator. Leah and Rachel did a very nice job of using the common denominator cos. I love how they had it written for all 4 of those. And for any place there was a cosine, they canceled it. These went away. That left them with sine times cos plus sine over cos x plus 1. And this is where your algebra starts to get deep. I can't replace anything else, but I'm clearly not happy with this. So I need to use a different technique from Unit 1, something we did daily but have not yet done. And that is what Colin just did in the back of the room, except he didn't quite do it right. Maybe he didn't do it. Maybe I just thought he did. It's an F word, but don't swear at me.
Foil.
The other F word.
Function.
Factor. I need to factor something. And when you're factoring with trig functions, it's a little uncomfortable because you're not just looking to pull out x's. You're looking to pull out whole functions. What whole function can I pull out here?
Cos.
Wait.
What's in both terms?
Post.
Cos
of X.
Sine x is in both terms. It shows up there and it shows up there. And watch what happens when I factor it out.
Now you can cancel it.
Bam, bam. My answer is
Sine x.
Sine x. Is example, I think 6 on page 29. It's 6A or something like that, but it's on page 29. Give this one a shot, please.
Where's the microphone?
Wait.
Okay, this one got a little bit trickier, and it was largely because of your algebra rules. You did have to change this tangent to a sine over cosine, and this cotangent to a cosine over sine. You had to then find a common denominator. The issue with finding a common denominator for a complex fraction is you need to put that common denominator both in the numerator and in the denominator. A lot of people I walked around, I saw only putting it in the denominator because the numerator seems so simple. Why disturb it? Well, because it's wrong if you don't disturb it. Once you've done that, you cancel what you had, and you are left now with a sine squared plus a cosine squared on the bottom. The denominators did collapse, but you still have a sine times cos on the top. At this point, you're done with the really hard part, but you do have to be able to visually see that this stinker is supposed to ring a bell. And the bell that it's supposed to ring is that it's a 1. which made your answer sign times cos. Have a seat.
Talking about.
You know,